Tabisas on Tandaway. GraphRAG, the RAG upgrade that actually understands connections. Let me start with a brutal truth. Most RAG systems aren't actually bad at finding information, they're bad at understanding relationships, and that difference becomes painfully obvious the moment you ask a question that requires more than one document. You can have 1,000 PDFs, 1,000,000 chunks, a beautiful vector database, and an expensive LLM sitting on top of it, and then you ask, how are these three things connected? Suddenly your brilliant RAG system starts acting like a librarian who has lost the index. That's where GraphRAG comes in. And no, GraphRAG isn't just RAG with a graph database. That's the lazy explanation. The interesting part is what happens when you stop thinking about your knowledge base as a pile of documents and start thinking about it as a network of relationships. Let's break it down. The problem with normal RAG. Here's the basic RAG architecture. You have documents, you split them into chunks, you turn those chunks into embeddings, you put them into a vector database, then the user asks a question. The system searches for chunks that are semantically similar to the question. Those chunks go into the LLM, and the LLM generates the answer. Beautiful, simple, useful, but there's a catch. Similarity is not the same thing as relationship. Imagine I give you 4 documents. Document 1 says, Company A acquired Company B. Document 2 says, Company B owns a subsidiary called Company C. Document 3 says, Company C manufactures a component used in Product X. And Document 4 says, Product X is responsible for 40% of Company D's revenue. Now I ask, how could Company A's acquisition of Company B affect Company D? That's not a simple lookup. You need to connect Company A, Company B, Company C, Product X, Company D. That's a chain, and here's where traditional RAG can struggle. It might retrieve the first document, maybe the third, maybe the fourth, but unless your retrieval strategy is extremely good, the system doesn't naturally understand. These facts form one connected structure. That's the problem GraphRAG is designed to attack. Pattern interrupt number 1. The light bulb. Think about Google Maps. If I ask, what's near this restaurant? You don't want Google to find places that merely sound similar to the restaurant. You want it to understand geography. This road connects to this road. This building is next to this building. This highway connects these 2 cities. That's the difference. Vector RAG asks, what looks relevant? GraphRAG asks, what is connected? And when your questions involve relationships, that distinction is enormous. So what is GraphRAG? At its simplest, GraphRAG combines retrieval with a knowledge graph. Instead of representing your knowledge only as chunks of text, you also represent important entities and the relationships between them. For example, Alice works at OpenAI. OpenAI developed GPT-5. GPT-5 powers Product X. Product X is used by Company Y. Now imagine that as a graph. Alice works at OpenAI. OpenAI developed GPT-5. GPT-5 powers Product X. Product X used by Company Y. Suddenly your information isn't just a collection of paragraphs, it's a connected network, and that gives the system something extremely valuable. Structure. How does it actually work? Let's walk through the pipeline. First, you feed GraphRAG your documents. That could be PDFs, research papers, company reports, internal documentation, emails, Wikipedia-style knowledge bases, basically, anything containing useful information. Then comes the interesting part. The system tries to identify entities, people, companies, products, locations, organizations, events, concepts. Then it identifies relationships between them. For example, NVIDIA manufactures GPUs. OpenAI develops AI models. AI model requires compute. Company purchases GPUs. Now you've got a graph, but we're not done, because GraphRAG can also identify groups of strongly connected information. Think of these as communities. Maybe one community is about NVIDIA's hardware, another is about AI infrastructure, another is about cloud providers, another is about model training. Now your system isn't merely storing individual facts, it's building a map of the knowledge domain, and that's where things get interesting. Shocker, pattern interrupt number 2. The real advantage. Here's the part people often miss. GraphRAG isn't primarily about making retrieval smarter, it's about making the context smarter. Because an LLM doesn't just need information, it needs the right information in the right relationship. Give an LLM 10 unrelated facts, and it has to figure out the structure. give it a connected subgraph, and you've already done part of the reasoning work. You're basically saying, here are the entities, here are the relationships, here is the neighborhood of information you should care about. Now reason over this. That's powerful. A realistic example. Let's say you're an investment analyst. You have 5,000 earnings reports, 2,000 company filings, thousands of news articles, supplier reports, patent documents, and industry research. Now ask, which companies could be most affected if NVIDIA experiences a major supply disruption? A traditional RAG system might search for NVIDIA supply disruption. It retrieves relevant chunks, fine, but the answer might require following several relationships. NVIDIA depends on suppliers. Those suppliers depend on manufacturers. Those manufacturers supply components. Cloud companies purchase GPUs. AI companies depend on cloud providers. And those AI companies have customers. That's a network. GraphRAG can model NVIDIA, supplier, component manufacturer, cloud provider, AI company, customer. Now your question becomes a graph traversal problem. And suddenly something that looked like a massive pile of documents becomes a connected map. That's the killer feature. But here's the part where I push back because GraphRAG has been hyped a lot, and here's the ruthless mentor reality. You do not automatically need GraphRAG. Please don't build a 47-component knowledge graph because someone on X told you vector RAG is dead. That's how you turn a weekend project into a 6-month engineering project. If your application is, what's the refund policy? You probably don't need GraphRAG. If your application is, how do I reset my password? You probably don't need GraphRAG. If you're searching product manuals for specific instructions, regular RAG may be completely fine. GraphRAG starts becoming interesting when the question looks more like, how are these things connected? Or, what caused this? Or, what entities are indirectly affected? Or, summarize the major themes across this entire collection. That's where graphs start earning their complexity. Pattern interrupt number 3. The test. Here's a simple test you can use. Take your application's hardest user question. Now underline every noun. Then draw arrows between the nouns. If you end up with something like person, company, product, supplier, regulation, market, you may have a GraphRAG problem. If you end up with question, answer, you probably don't. That's your decision rule. Not hype, not benchmarks, not someone's LinkedIn post, your actual query structure. Barnes, GraphRAG versus vector RAG. Let's make this brutally simple. Traditional RAG is excellent at, find me information about X. GraphRAG becomes more useful for, explain how X connects to Y through Z. Traditional RAG, give me the relevant documents. GraphRAG, give me the relevant entities, relationships, and surrounding context. Traditional RAG thinks primarily in chunks. GraphRAG thinks in connections. And the best systems, they don't necessarily choose one, they combine them. You can use vector search to find the starting point, then use graph traversal to expand the context. That's hybrid retrieval. And honestly, that's where I think a lot of production systems will end up. Not graph versus vectors, but vectors, plus graphs, plus metadata, plus structured databases. Use each tool for what it's actually good at. The big problem with GraphRAG. Now let's talk about the ugly part. Building the graph isn't free. You need to extract entities, extract relationships, resolve duplicate entities, deal with ambiguous names, keep the graph updated, and here's the nasty one, garbage in, garbage out. If your extraction model decides Apple means Apple Inc. when the document actually means an apple, congratulations. You just built a very sophisticated graph of nonsense, and errors can propagate. A wrong relationship can affect downstream retrieval, and now you're debugging not just your RAG system, but your knowledge graph. That's why GraphRAG isn't magic. It's an architectural trade-off. You get more structure, but you pay for it in complexity. Pattern interrupt number 4. The irony. Here's the irony. We're trying to build AI systems that can reason over complicated information, so we create a complicated system to help them reason, and then we spend our time debugging the complicated system. That's why architecture matters. Don't add a graph because it sounds sophisticated. Add a graph because your problem actually contains relationships worth modeling. Are you where GraphRAG gets really interesting? Now, imagine scientific research. You have millions of papers. A paper references another paper. That paper references a researcher. The researcher works at an institution. That institution runs a laboratory. The lab develops a technology. That technology is used in another experiment. Now ask, which research groups are indirectly connected to this emerging technology? That's not just semantic search. That's a graph, or cybersecurity. A vulnerability affects a software package. That package is used by an application. That application runs on a server. That server belongs to an organization. That organization depends on another service. Again, connections. Or healthcare research. A drug targets a protein. That protein is associated with a pathway. That pathway is associated with a disease. Another study identifies a compound affecting the same pathway. Now the graph starts becoming extremely useful. The future. RAG is becoming more structured. Here's my bigger prediction. I don't think the future of enterprise AI is going to be, put everything into a vector database and let the LLM figure it out. That's too simplistic. We're moving towards systems where different kinds of information are represented differently. Unstructured text. Use embeddings. Structured facts. Use databases. Relationships. Use graphs. Time. Use temporal metadata. User-specific information. Use memory systems. Then the orchestration layer decides, what information should I retrieve, from where, and how should I combine it? That's much more powerful than blindly throwing everything into a vector store. And here's the ruthless bottom line. GraphRAG isn't the replacement for RAG, it's an upgrade for a specific class of problems. If your AI needs to answer, what does this document say? Start with traditional RAG. If it needs to answer, how are all these things connected? Now you're entering GraphRAG territory. And if your system needs both, don't choose sides. Build a hybrid architecture, because the smartest retrieval system isn't the one with the fanciest technology. It's the one that retrieves the right context for the question. That's the entire game. And here's the uncomfortable truth. Most AI developers don't have a retrieval problem. They have a context problem. They keep giving the LLM more information, when what the LLM actually needs is better organized information. GraphRAG is one way of doing exactly that. So the next time somebody tells you, RAG is dead, don't believe them. And when somebody tells you, GraphRAG will replace vector databases, don't believe that either. The real future is messier. Vectors, graphs, databases, memory, agents, and LLMs sitting above all of them, figuring out which piece of the puzzle matters, because the winner won't be the AI with the biggest database. It'll be the AI that can find the right connection at the right moment. And that is what GraphRAG is really about. If you want to go deeper, the next question is even more interesting. Can you build a production-grade GraphRAG system yourself, with open-source tools and a normal GPU? Because that's where this stops being theory and starts getting dangerous.